Hi, I'm Alan Viverette, and I'm a technical lead on the Android Jetpack team at Google. I'm joined today by Anna Chiara Bellini, a product manager on Jetpack Compose. In this talk, we'll be covering the latest Jetpack libraries with a special deep dive on Compose integrations. As you may recall from previous years, Android Jetpack is a suite of libraries, tools, and guidance to help developers follow best practices, reduce boilerplate code, and write code that works consistently across Android versions and devices. In short, Jetpack makes it easier for developers to focus on the code they care about. Most apps are already using Jetpack's core libraries for basic functionality, but adoption of optional libraries like Room and Work Manager has continued to grow. Last year, over 3/4 of the top 1,000 apps relied on 2 or more non-core Jetpack libraries. And today, over 90% of the top 1,000 apps rely on Jetpack to address common pain points and make development easier. One major aspect of that is opinionated libraries focused on application architecture. Room is a database persistence library that provides an abstraction layer over SQLite to allow for more robust database access while harnessing the full power of SQLite queries. Most recently, Room 2.4 has graduated support for Kotlin symbol processing to stable, including support for Kotlin 1.6. KSP is a replacement for capt that processes annotations natively in the Kotlin compiler and can significantly reduce build times. Room 2.5 brings the initial stages of a full Kotlin rewrite. It remains binary compatible with the previous Java-sourced version, but lays the foundation for future Kotlin-related improvements. We've also introduced built-in support for paging 3.0 via the Room paging artifact, meaning Room queries can now return paging source objects. Additionally, Room has gained support for relational query methods using multi-map, nested map and array return types. This allows developers to perform join queries without defining additional data structures. For developers performing database migrations, Room has added additional properties and annotations to simplify the task. A new auto-migrations property on the database annotation can be used to declare which versions to auto-migrate to and from. And when Room needs additional information regarding table and column modifications, the auto-migration annotation can be used to specify the inputs. The paging library makes it easier for developers to load data gradually and gracefully within an app's recycler views or composed lazy columns. Paging 3.1 brings stable support for RX and Guava integrations, which provide Java alternatives to paging's native use of Kotlin coroutines. The library has also improved handling of invalidation race conditions with a new return type, loadResult.invalid, to represent invalid or stale data, as well as improving handling of no-op loads and operations on empty pages with the new on-pages presented and add-on-pages updated listener APIs. And to help developers ramp up on paging 3, we've added a simpler Getting Started Paging Code Lab on the Android developers site. The navigation library provides a framework for moving between destinations in an app, and the latest version includes quite a few improvements. First, the new Navigation Compose artifact provides integration between the navigation component and Jetpack Compose. It uses composable functions as the destinations in your app. Support for multiple backstacks has gotten easier as well. Navigation UI now automatically saves and restores the state of pop destinations, meaning developers can support multiple backstacks without any code changes. Large screen support has also improved, with the navigation fragment artifact providing a pre-built implementation of a 2-pane layout in abstract list detail fragment. This fragment uses a sliding pane layout to manage a list pane, managed by your subclass, and a detail pane, which uses a nav host fragment. Finally, all navigation artifacts have been rewritten in Kotlin and feature improved nullability of classes using generics, such as nav-type subclasses, with more usability improvements to come. The data store library is a powerful and reliable replacement for many shared preferences use cases. Last year, we showed examples of using data store, And this year, we're providing a new series of videos and articles within modern Android development skills focused on data store, including guidance on testing your app's usage of the library and using it with dependency injection. We've just covered some of our key architecture libraries. If you'd like to learn more about how they all fit together, we've created additional content in a series called Modern Android Development Skills Architecture. It's a collection of videos and articles covering best practices for modern Android development, including deep dives on the libraries that we've talked about today. We've also been hard at work putting together libraries to help developers assess and improve the performance of their apps. The JankStats library helps you track and analyze performance problems in your apps, including reports on dropped rendering frames, commonly referred to as jank. JankStats builds on top of existing Android platform APIs, such as frame metrics, but can be used down to API level 16. The library also offers additional capabilities beyond those built into the platform. Heuristics that help pinpoint causes of dropped frames, UI state that provides additional context in reports, and reporting callbacks that can be used to upload data for analysis. First impressions matter for users, and the speed of your app right after installation can make a big difference on user retention. To improve that experience, we've created baseline profiles. Baseline profiles allow libraries to provide the Android runtime with metadata about code path usage, which it uses to prioritize ahead-of-time compilation. This can make apps faster and reduce dropped frames the first time a user interacts with an app. This profile data is aggregated across libraries and lands in an app's APK as a baseline.prof file, which is then used at install time to partially precompile the app and its statically linked library code. We're already using baseline profiles within Jetpack. We've added baselines to popular libraries like Fragments and Compose to help provide a better end-user experience. To create your own baseline profiles, developers will need to use the macro benchmark library, which, in addition to helping with generating baselines, help developers better understand their app's performance and can be used to assess complex use cases, including app startup and integrated UI operations, such as scrolling a recycler view or running animations. Recent updates to the library have greatly increased testing speed and added several new experimental features, including custom trace-based timing measurements using trace section metrics, which allows developers to benchmark specific sections of code, audio underrun metric, which enables detection of audio buffer underruns to help understand audible jank, and baseline profile rule, which can generate profiles to help with runtime optimizations that we've just described. Baseline profile rule works similarly to other macro benchmarks, where you represent user actions as code within lambdas. In this case, the critical user journey that the compiler should optimize ahead of time is a cold start, opening the app's landing activity from the launcher. For more details and a full guide on generating and using baseline profiles with macro benchmark, check our guidance on the Android developers site. For developers interested in profiling their app's performance, the tracing library enables accurate event tracing in non-debug builds down to API level 14, similar to the manifest tag which was added in API level 29. Rounding up recent user interface changes, we've got developments in large screen compatibility, foldables, and emoji support. The new Window Manager library helps developers adapt their apps to new form factors, like foldables, by providing a common API surface with support down to API level 14. The initial release targets foldable device use cases, including querying physical properties that affect how content should be displayed, and future versions will extend to more display types and window features. Jetpack's sliding pane layout component has already been updated to use Window Manager's smart layout APIs to avoid placing content in occluded areas, such as across a physical hinge. The new drag and drop library also assists with new form factors and windowing modes, allowing developers to accept drag and drop data both from in and outside their app with a consistent drop target affordance, and it supports down to API level 24. Most developers will be familiar with the AppCompat library, which provides foundational backports of UI features like dark mode and tinting. Starting in 1.8, we've integrated AppCompat with the Emoji 2 library to bring default support for new emoji to all text-based views supported by AppCompat on API level 14 and up. We've also backported custom locale selection from API level 33 down to API level 14, including support for downloading additional locales using play splits. This is available in the latest 1.9 alphas of AppCompat and allows for manual persistence of locale settings across app starts. Note that you'll want to avoid storage mechanisms like shared preferences that perform disk access when you're storing your preferences. The feature also supports automatic persistence via a service metadata flag, which tells the library to load the locales asynchronously and recreate any running activities as needed. On API level 33 and above, however, persistence is managed automatically by the platform with no additional overhead. And now I'll hand over to Anna Chiara to talk about the latest in Jetpack Compose.
Compose has been stable since July last year, and it launched with a full set of UI components to allow you to build UI in a modern and declarative way. While it's been only a few months, we're seeing great adoption, with over 100 of the top 1,000 apps now using Compose. We worked closely with some of them in their journey to deliver UIs written in Compose to millions of users, and we have published several developer stories and case studies to show you how successfully they adopted Compose, even in the most critical parts of their apps, and how their productivity, code health, and delivery time have improved. If you search for anything on the Play Store or if you use Twitter communities, the UI you see is written in Compose. And today, you can learn about Airbnb's experience, so go check it out. But we know that we're not done. And in the last several months, we focused on adding features to support your most advanced use cases and making Compose as powerful as the view system, but way easier. Let's see what is new. As you progressively integrate Compose in your existing apps, you need solid, reliable interoperability between views and Compose, especially in common use cases like nested scrolling. Starting with Compose 1.2, embedding a scrolling composable in a coordinator layout is much smoother, and things like the collapsing toolbar are easy to set up. We are still working on improving all the possible permutations of views, recycler views, and lazy lists, so please continue to give us feedback. We know how important fonts are for your branding. Up until now, you had to either rely on fonts delivered with the Android platform, which can vary on different devices, or bundle fonts with your app, increasing the APK size. Starting with Compose 1.2, you can use downloadable fonts just like with views. You can express your brand at its best, while taking advantage of shared font caches and dynamic font resolution. One Compose feature that dramatically improves developer productivity is how you can use lazy lists instead of very verbose recycler views. But we know that your needs go beyond the simple rows and columns, so we're expanding the lazy loading of elements to more advanced layouts like grids and custom layouts. For details, check the lazy layouts in Compose talk. With Compose changing the way UI is created at a fundamental level, you need new tools to support your productivity. You've been asking for tools to understand and debug recomposition, and for faster updates. So if you've missed the What's New in Android Studio talk, I suggest you go take a look and see the exciting announcements. To help you make the most of Compose, we are publishing a set of new talks, code labs, and docs, targeting intermediate or advanced use cases. In particular, we've seen some developers struggle with writing a performant UI while getting used to the Compose programming model. The talk about common performance gotchas and the new documentation on performance should help you avoid those pitfalls. If instead you're just getting started with Android development or Jetpack Compose, we recently released the first few units of the Android Basics with Compose course. And if you're watching this talk on the I/O website, congratulations! You've just got yourself a new badge for your developer profile. You can earn up to 4 badges by completing 2 more steps. Take the Migrating to Jetpack Compose Code Lab and follow the Jetpack Compose setup guide. You can earn more developer profile badges for learning about our latest technologies. See how at g.co/learn-to-learn. In Android, we're full steam ahead with Compose, and we're not stopping at phone UIs. If you want to see how to go beyond resource qualifiers when targeting different device sizes, like tablets and foldables, you will not want to miss the talk about implementing Android apps for all screen sizes. And if you're taking your device reach a step further to Wear OS, you'll be happy to use the same intuitive, powerful Compose APIs for your app. Go check the talk to see how. And that's all for Compose. Back to you, Alan.
Thanks, Anakiara. Before we close out, I'd also like to talk about some recent developments in the annotations library, some additional talks, and our GitHub. The annotation library provides familiar annotations like non-null that pair with lint checks to improve the correctness and usability of code. First, and most importantly, we're working on migrating the annotation library to Kotlin sources. This means that Kotlin developers will see more appropriate annotation targets, including file, and that annotation now depends on the Kotlin standard library. We've also added a number of highly requested annotations with corresponding lint checks, including several concerning method or function overrides, and the deprecated since API annotation, which provides a corollary to requires API and discourages use beyond a certain API level. We also have exciting news for developers using the media libraries. Media 3 has launched, which includes the initial stages of merging ExoPlayer and providing a unified API surface. You can learn more about that in the What's New in Android Media talk. The fragment library has also been undergoing some serious changes. Check out the fragments, the good, non-deprecated parts to learn more about strict mode and other best practices for modern fragment usage. And continuing our themes of performance and compose, learn more about Compose performance with the common performance gotchas in Jetpack Compose talk. And finally, I'd like to draw your attention to our GitHub, where we now have over 100 modules, and more on the way, open for contributions using the standard GitHub-based workflow that developers expect. Please check the landing page for more information on how we handle pull requests and to get started writing code in Jetpack. You can learn more about recent Jetpack releases or check out the Mad Skills video series at our Android developers site. Thanks for watching.